So I'm David. I like hacking computers and stuff. I don't need to give too much of an introduction. Um, yeah, so my talk that I'm giving is scanning at scale, how we use Semgrep and CycloneDX at FanDuel. And this is a very unique and interesting problem that I've been thinking about for a while, and I'd love to share it with you. Maybe it's the other button. There we go. Yeah, so this quote really kind of describes what we're trying to do here is want the easy choice and the secure choice to be the same choice. Like we want our developers to be hitting that easy button to say like it's security should be an easy thing, and there shouldn't be too much thought that goes into these secure by default controls um, from a developer's perspective. That's the wrong button. Okay, so I need to hit down to go to the next slide. There we go. Yeah, so our problem statement is oh cool, I can see my slides right here, and then I can talk to the people on the Zoom as well. Nice. So our problem statement is what patterns currently exist across our code repositories. So coming into this, looking at it, I just wonder like what's actually in our code repos. This like the first thing that comes to mind is application security engineer who's supposed to be securing the code. What patterns should exist? Like, okay, now we kind of know what's in it. Like, what's that ideal state look like, and what does good look like for a source code repository? And then how aligned are the current patterns with the ideal state? So like taking what is there and then measuring it against what's ideal, and then being able to produce reports on that data. So we kind of look at the very simplest solution of this, and I've put a lot of pseudocode in this talk just to kind of like really break it down that style, because nobody really wants to look at like thousands of lines of Python when I'm giving a talk. So yeah, it's like for every repo in our repos, we just want to do the thing with that repo, where do the thing is a function we call scan. And we want to scan these code repositories and find some information out in them. And how about we take that scan information and the output of that scan function, and let's send that information to Datadog, where we can do queries against that data and find out some interesting things about our code. So that helps solve for that first point of what exists in our code repositories. So now get the idea. I'm like, okay, I've got this kind of basic pattern. We loop through our code repositories, we run some sort of scan function, and we send that information to Datadog. Now, how do we enable an application security engineer? Because what we want to do is make security engineering easier to write their own scans for the system. And how do we get it so we can enable execution of multiple of these application security engineer defined checks? So we just add another nested loop there, and we just say for every scan that's in our definition of checks, we just run that function, and we send them to Datadog. So scan all the things. Now, okay, cool. We've got like some basic pseudo code. We've got an idea. How do we scale this? Usually I just go for Kubernetes because I like it. No particular reason, cloud native and all that. Yeah, moving to the cloud solves all your problems. Put stuff in containers, Kubernetes. So we do something like this. We scan for every repo in our repos, spawn a Kubernetes job. So we can run these in parallel now. Now this isn't a single process that's doing this. Now we can scale our scans. Tim says I've not changed. Yes. And of course that doesn't work usually when you try it. It just, yeah, it blew up. It didn't work. Yep. This is fine. Yep. GitHub, they'll rate limit you. They're GraphQL APIs based on like complexity. So you have a complex GraphQL query, they'll just send you an assortment of error codes. Like maybe it's a 502, maybe it's a 504, 403, a 200, 201. Who knows? GitHub's just going to send you a random code back. Okay, so we got to solve this problem. Let's figure out how to do this. So, of course, I always like to build microservices because I think they're cool, just like Kubernetes is cool. So, yeah, we'll just fast API, Redis, and we'll combine that with the GitHub API, and we'll make this thing called Starfleet Nexus. I think of Starfleet Nexus as like intersection point of all this metadata from GitHub's going into. And I actually had ChatGPT write the name of this service. I was like, give me a service name inspired by nerd culture, and that's what I'm going to call it. So I got a list of names, and then I asked my coworkers on the AppSec team, I'm like, which one do you like? And that's how we named a lot of these services. So yeah, so then we iterate through our repositories now, and we just try and query the GitHub API until they give us the response we want, which I believe is 201. And then send that information over to Redis. So something to note here is in each code repository, we have a service data.yaml file. Contains information about ownership, attribution, other tags, lifecycle. Might as well collect this while we're iterating through these code repositories. This information will be very useful later. So as our API endpoint, now we can get information about repositories really quickly. So we just read it from Redis, and Redis is like, yeah, you can hit this API enough for our needs. We haven't had any problems with this service, at least at the current scale. So let's test out, let's see how this works in Kubernetes. You solved the scalability issues, right? It solved them, right? And yeah, now we're going to spin up 20,000 jobs on EKS, and that of course that's going to work. Yep. Just like that train. Yep. So yeah, they got this thing where the Kubernetes control plane on EKS doesn't want to grow proportionately with your workloads. So if you try and scale like how many things you're running in your Kubernetes cluster on EKS, it's just like, yeah, we can't actually scale the Kube API server fast enough to do the thing you're trying to do. I'm like, it's Kubernetes. I just want to run a ton of stuff in parallel. Like that's all I want to do here. So we'll just, yeah, we'll put a little FIFO queue in there, and we'll control the intake of work into our cluster that way. That way we don't spin up too many things at once, and we can make Amazon happy with their EKS scaling limits. So we'll iterate through our Kubernetes jobs. We'll say, okay, if we have less than 500 jobs in the cluster, then we'll pull off a job from our queue, and we'll put it into the Kubernetes cluster. And BL pop, that's a Redis primitive you can use to make these queues. It's a blocking list primitive, so it'll wait until something gets added to that list, and then your task can execute. So you can use it to build these queues. It's just what I grab to build queues, and other people might grab like an Amazon service or something else for this. There's tons of ways to make FIFO queues. Yep, and a timeout of 0 can block indefinitely. So we'll just set that to 0 and wait until we get some work back. And same thing, push. We can push stuff onto the queue. So these primitives have a right and a left side, so you can push to the right side and pull from the left side, or vice versa. Redis doesn't really care. Remember, 6 hours of debugging can save you 5 minutes of reading documentation. So yeah, before I jumped into that, I probably should have read the EKS docs that said, no, you can't actually scale that much. Everything's an API if you're brave enough. I always like that quote. One of my coworkers told me that once. I think it's cool. So we call this thing Kronos. And yeah, this is another ChatGPT wrote the name of the service, called it Kronos Time Warp Scheduler. I'm like, that sounds cool. Let's do that. So we built a service registry for all these scans. So we got this list of scans that we're iterating over. They're defined by application security engineers. So we need a place to store these. So we create this service that has a registry. So we just make create, read, update, delete functions for each check that exists in there. And a check is defined in a separate repository. So we want these, I don't really like the idea of making a central repository with every single check. Like I like the idea of anyone being able to write a check. Like maybe it's not even AppSec. Maybe there's like a DevOps team that wants to write a check to like find out some stuff about code, because there's this pattern of like scanning code repositories and discovering things about them is something that I think people that aren't in security would be interested in too. So it's designed in a way where like anyone can make a check. So it's just a separate repo. So it's defined by a schema, publishes a YAML file, which contains some notable things in here. It contains some other stuff too, which may be more specific to our environment right now. But as we consider open sourcing this, we'll have this really fleshed out. A container image reference. So each check is a container, because then I don't have to say, oh, you have to write your check in Python or you have to write it in X, Y, and Z programming language. I'm gonna be like, well, it's a container. So put some Rust in there, put some Bash in there, put whatever you want in there. I set the UID, GID to run as, because running containers as root is not good. Kubernetes resource requests and limits, like how big does what big of a workload does it need to run? Like Semgrep, I know it takes like 5 gigs of memory to run. So yeah, we set those resource limits there. That's important. So then you're defining that information up front, and your scan's not running out of memory when you're running the scan. And then we just inject with Kubernetes secrets, for instance, Semgrep app tokens, so we can talk to the Semgrep API inside of our scan environment. And it's picked up by CI/CD, and then it's published to this endpoint. So we just put request or post request to this endpoint, do our create, read, update, delete. So create new scan, update existing scan. And this pattern of a YAML file pushing to an API could evolve into a Kubernetes operator that like reads configuration from custom resource definitions. Could be the future of how this works. I kind of built it open-ended, and I like the idea of things living on the control plane, but it doesn't have to right now. And then we got another endpoint, which triggers these scans. So this just iterates through the list of checks, which we now know is in our database because we posted the checks to our endpoint. And then we just enqueue it, add it to that Redis queue, and then we get an ID back. And then that ID can be traced through our Datadog environment, and we can find the output of that specific scan. And we can run these checks against a single repository. That's how this endpoint's designed to scan everything. We iterate through the list of repositories in Starfleet Nexus. That's that GitHub wrapper service that I mentioned earlier. So that knows what repos exist in our org. And it's a reliable source for that information that's not going to throw us random error codes. So we go through that list and we just scan everything. Containers running at last. And then we forgot something in the Docker file. So with these repositories, we kind of have to have a way to clone them, right? So in our Kubernetes environment, we've got to have this like place to put them. So we create an empty directory, which Kubernetes just folder that stuff can go into. And then we mount that. And we do git clone bear. Reason we do that bear clone versus a shallow clone is when we run our secrets check, we want to scan every single thing possibly in every single branch, because if it's secrets in Git, it's in Git. So if we don't, like, if it's just in like the last few commits, it's still in Git. So like your Git history tells everything about your secrets. So we do bear clone for the purpose of scanning secrets. I've thought about like architecting like a way to like do bear versus shallow, but it doesn't add too much computation time to it. Like our scans mostly run long due to other reasons, not Git cloning. So right now we just bear clone because it's it works for both cases. And importantly, we take that UID, GID information, then we change ownership of it. So now our container owns the repo it just cloned. So we do this all inside of a init container, which runs before the main container runs. And then this just is a pattern that happens for every scan. So scan doesn't have to care like how the repo got there. It just gets dropped into this mount path, and then the scan can like do the thing against the repo. It doesn't have to care like, how do I clone a repo? How do I iterate through the list of repo and solve this problem once? Yeah, and you probably don't want to look at like how we're actually doing the git clone, and I'm not gonna go over that in this talk. But we got a better solution that we'll release before we make this open source. Hey, but that's nice. I came to this talk for the SBOMs. Yeah, I had to give the introduction to like how this scanner system works before I drop the SBOMs. Yeah, so the core concepts here with this data schema is a JSON output of a scan is structured into these events, single lines of minified JSON sent to standard out. And then our Datadog integration just aggregates these and picks them up. And you could, like, I imagine like an open source version of this having a world where this Datadog thing gets swapped out with some other tool that does logs like Elastic or Splunk or whatever. This main thing is it's JSON sent as minified lines to standard out, and like whatever tool wants to slurp that up, certainly could. Yeah, so we can, because it's JSON output, we can dynamically add fields to this JSON structure, which is where the service catalog comes in, and this can be super powerful pattern. So this is kind of what the data schema looks like. So we've got our schema version at the top, and I tried to make this in a way where I'm not going to give you death by JSON files on this PowerPoint. So yeah, and then we say like, where did this event come from? Like what scan specifically sent this off? And then we say like what type of event it is, because we could say this is a vulnerability event, like we detected a vulnerability in this code, or this could be some other event like we detected this file exists. Like I always think of like the most basic chronoscan that could exist is like, does this file exist in this code repo? And I know you probably could do that with like a GraphQL query in GitHub. But what Chronos gives you is this ability to write any sort of code and detect code as code. Yeah, so this gets our vulnerability information and score, severity, all that fun stuff. And we get some metadata from the GitHub API, like which branch was this on? Does this repo have Dependabot turned on or not? This was like one of the first things that Jerry asked me to do when I was building this, is like, we just need to know if our code repos have Dependabot on and like which ones have it on. So I just added that as, that was like one of the first things we built into this. And like what the visibility is on it, because if you're sending this information to a SIEM, you could have the data from this say like, okay, we detected a repository is public and we don't actually want public repos. So we're gonna make this fire off a detection or automated response. What GitHub org it came from. if the repository is empty, if it's archived, how many commits, what languages are present in it, can be very useful when you're designing scans for SCA and you want to know, okay, we've got this SCA scan that's supposed to be covering our JavaScript repos, but it's not actually covering all of them. And this will allow you to like determine that, because you can say this repo's got JavaScript, CSS, HTML shell, but we didn't get any vulnerability events back from this. And more metadata from the service catalog. So like what team owns it, what tier of service is it, what the life cycle of that application is. So like, is this a production app? Is this P1? Okay, that can like add some context to these vulnerabilities as they're getting emitted by the system. Who was the last committer, or what was the commit hash on this specific thing we scanned? Right now, we're just scanning main branches, just to get information, but I imagine a world where we can scan like individual commits, because that wouldn't be too hard to do, because we check out the repo on whatever commit. Yeah, so this is how this works in practice. So CycloneDX, for those of you who don't know, is an SBOM format, software bill of materials. It describes all the things that go into the software. Basically, you can kind of think of it like in Node.js, like you package lock JSON that has always like a bajillion different NPM packages in it. Like that's kind of what an SBOM looks like. CycloneDX is an interesting and unique format because you can also annotate vulnerabilities inside of that. And you can say like this dependency is in our dependency chain, but it also has this critical vulnerability in it. And you can exchange both the dependency tree and vulnerability information in one single file, which is where this comes in handy for aggregating vulnerability events. So this allows us to decouple our system from the tools that we use. And we can just say, we work with tools that support CycloneDX, and then we can plug them into this system we built. Yeah, so local container file system. We got our CycloneDX information. We send that to a tool we wrote that creates these vulnerability events and sends them to Datadog. And the Chrono schema annotate is what it takes in the output vulnerability event, and then it adds on those extra fields like lifecycle. So all that extra information gets added to anything. So if we're not sending vulnerability events, we're sending like file exists in repo or some other information, everything's going to be getting tagged with that information. And because it's code, we can change how it's getting tagged, changing that. So we pull local file system, get information, branch, commit, etc. And then that stuff from Starfleet Nexus, GitHub, pull that information there, and we combine them into one single format. So then we run Semgrep CI inside of these scans. So for those of you who haven't used Semgrep before, when you have the cloud platform integration, like it's just one command and it's pretty much zero config then, and you just run Semgrep CI, and then it does the scan and then uploads those results to your cloud instance based on your secret key that we give in this environment. And so we run that ahead of time, and then we call the Semgrep API, and Semgrep API gives us the CycloneDX format. And then we take that and run it through the system. So it allows us to use Semgrep to get this vulnerability information. We also can use like Gripe or any other open source tools that do these vulnerability scans, and we can pull all of this information together into a single unified platform. And because this is these little individual pluggable pieces, we could introduce a step in here that's like, take that SBOM output, and each of these scans is ephemeral. So when the scan's done, like it's gone. Like whatever happened in there is gone. It just leaves the evidence of what happened with his log output. So we could introduce like something in this pipeline that just takes that CycloneDX, uploads to a bucket. Something I've heard that when you're first starting to work with SBOMs, like if you don't know what to do with them and you're like, hey, I made an SBOM, what do I do now? Like just start throwing them in an S3 bucket. Because if you ever need those someday, then you have them. Then you can say, where's all my 0 days? And you can go write some JQ really quick and pull your SBOMs out of your bucket and like find that 0 day vulnerability when it comes out. It's better than not having the SBOM. So if you're thinking about SBOMs, you're starting to work with them, like a simple thing you can do is just start throwing them in a bucket. Yeah, so that's kind of how this integration works with Semgrep. And that's all I really got for my talk. I don't know how fast I blew through these slides. Jerry was doubting that I had like 50 slides and how long it would take. How long did that take me? Was 25 minutes. So I did it in like half time, which leaves like plenty of time for questions here, which is cool. Yeah, unless you're trying to like sell me something. I mean, I'll talk to vendors sometimes. I like Semgrep. They're pretty cool. Yeah, we got questions and answers. Yeah. Probably to the mic for those on the.
How does this fit into engineers and developers developing and merging and deploying code?
Is it working now? Okay, cool. Yeah, so I'll re-say what I just said. So we think of this kind of in two paths. So what I went over in this deck is the green path. What we think of. We think of this as scans that happen no matter developers know about them or not. We're just scanning. We're collecting information, and that information allows AppSec to make data-driven decisions on like what scans we build next, for instance. But what we think of for the developer experience, where this really gets involved with developers, is kind of a phased approach to that. So what we call that is our orange path. So that's where these checks are integrated into CI/CD pipelines. Now with CI/CD pipelines, generally there's some sort of file that exists in your code repository, usually some sort of YAML like GitHub Actions, BuildKite, etc., or like a Jenkins file if you like Jenkins. Jenkins is interesting, and yeah, and so these are all artifacts that can be scanned as code. So our green path can actually look at these files that describe the pipeline and then output information about them to us. So we can say, how many code repositories have a pipeline that looks like this? And then we can define what that looks like. So we can use that to shape our CI/CD pipelines. Another way we can get in the developer experience is taking data from our green path and our service catalog and using that to drive something like Datadog service scorecards, which allows us to like gamify the application security process. So we can assign a score based on things we find, and we can say like, okay, this thing that we've found in this repo, this low vulnerability has affected your score by X number of points. I don't think we'd actually affect the score by low vulnerabilities, but I don't think we're that rude. But yeah, that's just different ways you can use this system to drive that developer experience.
Gotcha. Thank you.
Yeah.
Hey, David, thank you for giving this tech talk. So I'm a software engineer myself, and I came to this to just familiarize myself with cybersecurity principles. Can you elaborate on what an SBOM is? I don't know what that is, and maybe how a software engineer like myself can avoid dropping one.
For sure. Yeah, so an SBOM is an artifact that usually looks like a JSON file that has a specification that's usually written by some governing body. In this case, CycloneDX is written and published by OWASP. And there's also the other format that we talk about, SPDX, which is published by the Linux Foundation. And they each have their pros and cons. And I I can't get into the politics of that too much, but yeah. Yeah, so this bill of materials is something that you can produce programmatically with a tool, for instance. So what's your primary programming language you work in?
TypeScript.
TypeScript. Okay, cool. So for a TypeScript repository, you'd have which I know there's a bajillion JavaScript ecosystem. Is it Yarn or is it npm or something else? Okay, so npm, you have your package.json file. Do you commit package lock to your repo when you develop? No, that's usually the first step when we're working with developers, is getting those lock files committed to code. Because when you're talking about supply chain vulnerabilities, you're either explicitly accepting risk or you're implicitly accepting risk. And by committing a lock file which has the full dependency tree, you're changing that implicit acceptance of risk to explicit, because now you're saying like, okay, I changed this dependency and then all of these sub dependencies change at the same time. And now that goes in your pull request review, and you've got that whole giant, it can be a little annoying. Like I've definitely worked with big projects with lots of developers where a node project can like you're like constantly rebasing, and then that package log file, like it's just it gets a little crazy. But there's a good reason to why it's done that way, because that allows you to know exactly what components are going into the software you're shipping. So when you pull a JavaScript dependency, I think there's an npm dependency called everything that pulls everything in npm. I can't remember if this still exists, but it'll like super break your workstation. But yeah, something like that just has this like huge like dependency tree. But SBOM kind of takes that further, and you could say like, okay, in my JavaScript project, maybe we also have some Python code mixed in there. Like, let's say, for example, you are writing a project where your front end is a React app and it's all written in TypeScript, and your back end is Python. And for some reason, you've decided to put all these into a single repository. I've definitely seen that pattern before. So now you've got these two things that make up this thing you're deploying. And SBOM allows you to like have a list of all your Python dependencies and your node dependencies all in a single file. And you know, like this is what makes up this project. And then there's security tools that are built on this, so they can take every single dependency in that dependency tree, and it can say, okay, what versions of this package are vulnerable, and what are the vulnerabilities, and how are they ranked? We can use that information to determine like if we're going to block this from getting deployed to our production environment. Does that help with your question? I'm happy to talk about SBOMs more, or really any topic. I can talk for a while.
Talking about how we're using SBOM as a unified format for all our tools. I think you touched on a little bit, but like, you know, to his question about the, you know, the software bill of materials, it's basically how we're annotating all our vulnerabilities. It's how we're understanding, you know, the whole supply chain of risk with our vulnerabilities. So us having a unified way of doing that is super powerful. It's like we can hook in Semgrep, we can hook in, you know, OSS tools. It just gives us a whole lot of flexibility in how we're doing SCA scans.
Yeah, because otherwise, as an engineer that's trying to implement security, and I work with a whole bunch of different tools, and each tool is like, we're going to have this API in this format, and we're going to give our vulnerabilities in this format. It's like, no, this is madness. Otherwise, on our end, we just end up kind of building the same thing. So it makes sense for like a body like OWASP to like build this format once and do it in one place. And as a security community, we can kind of move past that.
Someone online has a question. Tim says, How do you avoid someone making duplicate scans or too many scans?
Too many scans, duplicate scans. That would start with good authorization and authentication. So you know like who's performing that scan, and we actually don't have any of this in place right now, but well, it'll definitely be something that we add as this platform matures. But having like audit logs, like who scanned what and when did they scan it, and or was the scan kicked off by automation, or like being able to stitch that story together with good audit logs, I think is key. And then you could also, like if you wanted to like commercialize this or something and say that like anyone can make a scan, you could have some controls, like you can put rate limits per account. Like there's lots of different creative ways you could solve that. I think right now we don't really care who makes a scan and how many scans they make, because the only people really making scans are AppSec engineers that know how this works. So it's a little bit of security by obscurity. Also, you have to be on our VPN to use it.
Cool. Anyone else have questions? Can we do it on here?
You're generating the SBOMs and everything, and then presumably you're taking those source repos and they end up getting built into containers and things like that. Do you have a linkage from like, say, a running container in a Kubernetes cluster back to your SBOM source material, or how is that something that you would expose to like an SRE kind of person?
Yep, that's a great question. So one way we do that is through our Datadog integration. We just kind of go with what they say, like how they say a container should be built to get tagged in their unified telemetry, which to us just looks like some Docker args that get passed in at build time. And then those args get set in environment variables. And then when this container is running on the cluster, the Datadog agent knows about those environment variables. And then the Datadog tracing library that's running in there via APM can pick all that up, and we can trace that container back to code. And what's cool about that is there's a section there for commit ref. So we can say which commit this container came from, which is really nice to know when you're like trying to backtrack what happened in production. So I think that's something that like hopefully your SRE team wants and has set up. And if they haven't, as a security practitioner, you can kind of say that that's something that we definitely want.
Okay, we have Grace online has quite a few questions. So we'll take it one by one. Was the choice to use Semgrep intentional, meaning when presented with both commercial scanning tools and other open source solutions, Semgrep was the best choice for you guys, or was there an open source solution preference?
Yeah, so actually that's an interesting question, because we started this out with actually the first scan wasn't either of those. It was just a tool that we built, and all it did was check that Dependabot is on or not thing. So we didn't even have open source or commercial. It was just all internal. And then we went to we started integrating an open source tool called Gripe. It's by Anchor. They also make Sift, which produces SBOMs and can convert between different SBOM formats. So if you want to play with SBOM, Sift is a pretty cool tool for that.
How do you spell that?
SYFT, Sift. Yep.
I had a feeling it was funky.
Yep.
Go on to the next question.
Yeah, I can continue to elaborate on that one. So we were looking at we did internal, then we did open source, and then we'd always thought about building Kronos in a way where we could run commercial tools inside of it. Like we didn't want to care like if the tool is commercial or not. And then so I'd already been thinking about, well, a commercial tool, it's going to have some sort of API secret that interacts with the commercial API, so that I kind of built that in mind, that like these scans could take in some sort of API secret, because that's usually how these commercial tools work. And then we did our internal evaluation of what tools were the best fit for us, and Semgrep ended up being one we chose.
Cool. How do you guys collate the scans finding results for reporting? what does the feedback loop look like? Does it push the scan result back to the repo as an issue, or would it be possible to return the scan results if kicked off from a PR as a PR review?
Yeah, so that's interesting. So there's a couple things in there. So interaction with a pull request directly, we consider that as part of our orange path. So that part of our scan will go into the PR, and it can add comments to it. We can also, that's where we integrate our Semgrep platform integration, where Semgrep can go in and make comments on these pull requests and make suggestions. And then as far as like filing an issue, that's not something we currently do, although we could. As far as like how we make this data valuable, so I'll get sent to Datadog, and then in Datadog, we can build dashboards based on our data. So since we have team information, we've got vulnerabilities, we got the severity of them. At a minimum, we can take all this and we can build a dashboard that someone can put in the drop-down selector, select what team they're in, and then see what the landscape of their vulnerabilities looks like in their code. So that can be a place that we can put in the hands of our developers so that they can start to action on these things organically. And we've also considered how to integrate this into a formal vulnerability management process and vulnerability management platform. So I've actually been working with GULED, and we've been building out a way for enterprise security to front the vulnerability management platform with an API that accepts CycloneDX SBOM plus our annotations on who owns it. So then on their side, they can say, okay, this vulnerability was found, and now we've attributed ownership of who owns that vulnerability. Because what we don't want to do is put a whole bunch of vulnerabilities into a vulnerability management system and then not know what team to even go to like fix them. So it's all about making the data useful.
We should also mention that like the vulnerability management path is like our backstop, right? So orange path is, you know, in the pipelines and like introducing those pipeline scans to the developers and getting them, you know, to crawl, walk, run by, getting the feedback, fixing it in the pipeline. That's where we're trying to partner most and try to get that out. Where, like David said, like orange path is where we're really trying to get things first.
That's Jerry, everyone online.
Shift left.
Okay, last question from Grace. Have you guys ever considered using dependency track to feed your CycloneDX SBOMs generated files?
Yeah, that certainly could be an option. I've checked that out before in the past because I've done some work with SBOMs before. I think that's one of the powerful things about revolving around a format like this is like there's a whole ecosystem of tools out there that can work with this format. So it just gives us lots of options on how we can do this.
Awesome. Any other questions? Comments? Ideas?
Yeah, I did this all in PowerPoint. Oh, thanks.
Tim says, I need your budget. Grace says, thank you. Smiley face.